you've been told a lie. A very comfortable, very intuitive, and completely wrong lie. You look at a beam of light, maybe from a flashlight or a distant star, and you think, wow, that thing is really moving fast. You think of light as some kind of cosmic sprinter, a champion runner breaking records across the vacuum of space. But I'm here to tell you that from the perspective of the universe, light isn't traveling at all. In fact, light is the only thing in existence that is truly, deeply, and utterly stationary in time. Now wait, don't turn away yet. I know it sounds like I've had one too many drinks at a faculty party, but bear with me. We have this idea that space is one thing, a big empty stage, and time is another thing, a clock ticking away in the background. We think we can move through space as fast as we want, and time just keeps on ticking at the same rate. It's common sense, right? Well, nature doesn't care about your common sense. Nature is much more peculiar, much more beautiful, and much more restrictive than you imagine. The truth is, you are moving at the speed of light right now. Yes, you. Sitting in your chair, holding your phone, or leaning against a wall. You are rushing through the universe at exactly 299,792,458 meters per second. The catch? You're doing almost all of that traveling through time, not space. By the time we're done here, your entire concept of speed is going to collapse. We're going to peel back the skin of reality and look at the gears underneath. And I promise you, once you see it, the world will never look the same again. Now, why does this matter? Why should you care about some abstract limit on how fast a photon can wiggle through a vacuum? Because this isn't just physics trivia. This is the fundamental architecture of your life. Every second you age, every mile you drive, every star you see in the night sky is governed by a single, unbreakable budget. If you don't understand this budget, you're living in a hallucination. You're like a fish who doesn't know it's in water. Most people go through their whole lives thinking they are standing still when they are actually hurtling through the fourth dimension at a breakneck pace. We're going to decode that. We're going to look at why the universe sets a speed limit and what happens when you try to break it. This is not just about numbers. It's about how reality itself is stitched together. But why? Why does it happen? Is it because the universe is lazy? No. It's because the universe is efficient. It's because space and time aren't separate things. They are two sides of the same coin. This is not just physics. This is how reality works. If you want to join us in decoding the universe, and you want to see the world as it truly is, hit that subscribe button. Let's find things out together. Let's start by deconstructing what you think you know. Think about a car on a highway. You're doing 60 miles per hour. You step on the gas, you go 70. You step on it harder, you go 80. In your mind, there's no reason you couldn't go 200 or 2,000 or 2 billion miles per hour, provided you had a big enough engine and enough fuel. Your intuition says that speed is additive. If I'm on a train going 50 miles per hour and I throw a baseball forward at 50 miles per hour, the guy standing on the side of the track sees the ball going 100 miles per hour. Simple. Easy. Wrong. It turns out that's not how the world works. It's just an approximation that works when you're moving slowly. And believe me, compared to the universe, 60 miles per hour is practically standing still. For a long time, even the smartest guys, the Newtons of the world, thought time was absolute. They thought there was a master clock in the center of the universe that ticked at the same rate for everyone everywhere. They thought space was just a big empty box. But why did they think that? Imagine a deck of cards. You lay them out one by one. Each card is a moment. You think you can just shuffle them faster or slower, but the cards themselves stay the same. That's how Newton saw the world. But then we started playing with light, and light did something very, very naughty. It refused to follow the rules. If you're on that same train going near the speed of light, and you shine a flashlight forward, the guy on the tracks doesn't see the light going light speed plus train speed. He just sees light speed. No matter how fast you go, light always stays at the same speed. It's like a phantom that refuses to be caught. Imagine a little ant crawling across a table. To the ant, The table is the whole world. Now, imagine the table starts moving. You'd think the ant would move faster relative to the floor, right? But what if, no matter how fast you pushed that table, the ant always crossed it at the exact same pace? You'd think the universe was broken. You'd think there was some kind of speed police enforcing a cosmic law. The old scientists were baffled. They tried to invent things like the ether, a weird invisible jelly that filled space, to explain it. They thought maybe the Earth was dragging this jelly along with it. They did experiments, like the Michelson-Morley experiment, trying to find this jelly. They spent years, used giant slabs of marble floating in pools of mercury, trying to catch a wind of this jelly. And they found nothing. Zilch. The jelly didn't exist. The speed of light was just constant. It didn't care about your train, your planet, or your flashlight. This is where everyone gets stuck. They ask, why can't I go faster than light? But that's the wrong question. The real question is, what is speed anyway? You see, we've been looking at the map wrong. We've been treating space and time like they're two different countries with a border between them. But they aren't. They are the same country. It's a place called Spacetime. And in this country, everyone is given the exact same speed budget. Now, let's get into the heart of it. This is the deep dive. This is where we look at the mechanism. I want you to imagine something very specific. Forget about kilometers and hours for a second. Imagine you have a compass, but this isn't a normal compass that points north, south, east, and west. This is a space-time compass. One axis represents space, all the directions you can move, left, right, up, down, forward, back. The other axis represents time, the direction you move from yesterday toward tomorrow. Imagine it like a rubber sheet stretched tight. If you pull it one way, it has to give in another. Now, here is the secret that Einstein uncovered, the thing that makes your head spin. The universe has a fixed, unchangeable velocity for everything. That velocity is the speed of light. Every single object in the universe, you, me, a planet, a ham sandwich, is always moving through space-time at exactly the speed of light. Wait, why? Why can't we change it? Because that's the only way the math holds together. It's the jiggle of the universe. Imagine a swarm of bees. If they are all flying at exactly 10 miles per hour, they can fly north or they can fly east. But they can't fly 10 miles per hour north and 10 miles per hour east at the same time. If they want to go a bit east, they have to sacrifice some of their northward speed. You might say, Feynman, you've lost it. I'm sitting still. But you aren't. You are moving through time. If you are perfectly stationary in space, all of your speed budget is being spent on moving through the time axis. You are rushing toward the future at 300,000 kilometers per second. That's why clocks tick. That's why you age. You are using 100% of your cosmic energy to move through the dimension of time. Now, imagine you start to move through space. You get in a rocket and you start zooming. What happens? To move through space, you have to borrow some of your speed from your time axis. It's like a vector. Imagine an arrow pointing straight up toward time. If you want that arrow to point a little bit to the right, toward space, the arrow has to tilt. And when it tilts, it doesn't reach as high up as it did before. The more velocity you use to travel through space, the less velocity you have left to travel through time. Think of it like a car that has a permanent stuck cruise control at exactly 60 miles per hour. You can't go faster and you can't go slower. If you drive exactly north, you're doing 60 miles per hour north. If you start turning a little bit east, you're still doing 60 miles per hour total, but you're no longer doing 60 miles per hour north. Your northward speed has dropped to, say, 50 miles per hour, because some of that 60 miles per hour is being used to go east. In our universe, north is time, and east is space. When you move through space, your speed through time slows down. This is what we call time dilation. It's not a mechanical error with your watch. It's not that the batteries are getting weak. It's that you are literally diverted away from the time dimension. You are spending your budget elsewhere. Let's look at what I call Feynman arrows, what we physicists call vectors. Imagine a little arrow representing your total motion. The length of this arrow is always fixed at the speed of light. If the arrow is pointing straight up into the future, you are aging at the normal rate. If you start moving through space, that arrow tilts. The horizontal part of the arrow is your speed through space. The vertical part is your speed through time. Now, look at what happens when you push it to the limit. You keep tilting that arrow. You go faster and faster through space. The arrow tilts lower and lower. Your speed through time gets smaller and smaller. Clocks on your ship start to crawl. 1 second for you takes a year for the people back on Earth. But what happens when the arrow is perfectly horizontal? When the arrow is horizontal, you are using 100% of your budget to move through space. You have 0% left for time. You have reached the limit. You are now a photon. You are light. And here is the mind collapse. Because a photon is using all of its speed budget to move through space, it has 0 speed left to move through time. For a photon, time does not exist. It doesn't tick. It doesn't age. It doesn't wait. From the moment a photon is emitted from a star 10 billion light years away to the moment it hits your eye, 0 time has passed for the photon. For you, it took 10 billion years. For the light, it was instantaneous. It was born and it died in the same heartbeat, or rather, it had no heartbeat at all, because a heartbeat requires a before and an after. And light has no after relative to its before. But why can't we just add a little bit more? Why can't we have an arrow that is longer than the speed of light? Because the geometry of space-time won't allow it. It's like asking why a circle can't have more than 360 degrees. It's not a matter of power or technology. It's a matter of the definition of the shape itself. Speed is just the angle at which you are traveling through the block of space-time. Think of it like this. If you have a piece of paper and you draw a line across it, the line can only be as long as the paper. If you want to go further, you need a bigger paper. But the universe is the paper. The size of the speed budget is a fixed property of the vacuum itself. It's not like A, where you hit a wall. It's actually like B, where you've simply run out of directions to turn. You see, the reason you can't go faster than the speed of light is the same reason you can't go more north than the North Pole. Once you are at the North Pole, every direction you turn is south. Once all your velocity is in space, there's nowhere else to go. You can't borrow more speed, because you're already spending the whole budget. There is no extra speed. The speed of light isn't a speed in the way we think of it. It's just the total magnitude of our existence in 4 dimensions. It's like a jiggle. Everything in the universe is jiggling. If you jiggle in one direction, you can't jiggle as much in the other. It's a conservation law of the most fundamental kind. You are a 4D creature, and you are always moving at the maximum speed. You just happen to be doing most of it in the direction of next Tuesday. Let's sit with that for a moment. Think about the implications. This changes everything about how we see the cosmos. If time is just a direction we are moving in, and we can tilt our path to move through space instead, then the past, present, and future aren't what they seem. Imagine the universe as a giant loaf of bread. This is the block universe idea. Every slice of the bread is a moment in time. Normally, we think we are a little person walking through the bread, slice by slice. But if you start moving fast through space, you're not slicing the bread straight across anymore. You're slicing it at an angle. Your now is different from my now. If you're moving fast enough, your present might include my yesterday or my next Friday. This isn't science fiction. This is the geometry of the world. It means that, in some sense, the future is already there, and the past hasn't actually disappeared. They are just different coordinates in the loaf. But why is the future already there? Because if you can tilt your perspective, you can see parts of the loaf that I haven't reached yet. Imagine 2 people standing in a field. One is looking north, one is looking east. What is ahead for one person is to the side for the other. In space-time, What is future for me can be space for you if you are moving fast enough. This brings us to a state of existential awe. We think of ourselves as these very important, very busy people moving around on a planet, but in reality, we are just objects that are frozen in space relative to the speed of light, which allows us to experience the flow of time. If we were lighter, if we had no mass, we would be like light. We would be everywhere at once. We would have no history. We would have no story. To have a story, you need to have a time speed that is less than through space. You need mass. Mass is like a cosmic anchor. It's the thing that drags on you, that prevents you from tilting your arrow all the way to the horizontal. Mass is what forces you to move through time. Think about that. Your very existence, your ability to think a thought, to remember your childhood, to plan for a vacation. It all depends on the fact that you can't go at the speed of light. If you were perfect, if you were pure energy, you would be timeless. You would be a static point in the geometry of the universe. We are broken light. We are what happens when energy gets tangled up in itself and slows down in space, which forces it to start rushing through time. We are the universe's way of turning speed into duration. Every gray hair on your head, every tick of the clock on the wall is just the result of you not moving fast enough through the room. Aging is just the leftover speed from your journey through the void. It's a bizarre trade-off. We give up the ability to be everywhere at once so that we can have a now. We give up the speed of light to gain the experience of living. When you look at a star, you're looking at something that has no sense of time. But you are a time traveler. You are moving through the fourth dimension at a speed that light can only dream of if light could dream, which it can't, because dreaming takes time. So, what have we uncovered? We've seen that the speed limit isn't a wall. It's not like there's a cosmic policeman standing there with a radar gun saying, "Whoa there, buddy! Slow down!" It's a geometric limit. It's the total amount of motion available to anything in this universe. The speed of light is the total velocity budget of space-time. You are using it to age. Light uses it to travel. Nature is absurd. I've said it before, and I'll say it 1,000 times. It doesn't make sense to our monkey brains, because our brains evolved to catch bananas and avoid tigers, not to calculate 4D vectors at relativistic speeds. But that absurdity is where the beauty lies. It's the fact that the world is so much weirder than we could have ever imagined that makes physics so much fun. But why is it fun? Because it means there is always more to find out. It means that the universe isn't just a boring machine, it's a masterpiece of subtle design. We don't know why the budget is $299,792,458 meters per second. We don't know why it isn't twice that or half that. Nature is just that way. It's one of those fundamental numbers that we just have to accept. But the mechanism, the way it ties space and time together into a single, elegant fabric, that is something we can understand. That is something we can visualize. The next time you're out at night and you look up at the stars, don't just think about how far away they are. Think about the light traveling from them. Think about the fact that for those photons, no time has passed. They are fresh from the Big Bang, or fresh from the surface of a star, even if they've been traveling for billions of years. And then look at yourself. Feel yourself rushing through the dimension of time. Feel your speed budget being spent on this very moment. You are a traveler in the fourth dimension. You are moving at the speed of light right now toward a future that is already written in the geometry of the loaf. Nature is absurd, but that's what makes it beautiful. If you enjoyed this journey, share it with someone who needs to have their mind blown. And don't forget to subscribe. The universe is full of these little secrets, and I'm not done looking for them yet. There's always something more to find out. The universe is waiting. Go out there and look at it. Don't just take my word for it. Look at the world. Ask why. And don't stop until you find an answer that's at least as crazy as the one I just gave you. See you in the next slice of the loaf. Wait, let's look at one more thing. Imagine if could break the limit. Imagine if you could push that arrow past the horizontal. what would happen? The arrow would start pointing times downwards, asterisk. And what is down on the time axis? It's the past. Going faster than light isn't just about moving through space quickly. It's about reversing the flow of time. It's about turning your next Tuesday into last Wednesday. But the universe prevents this because it would break causality. It would allow you to kill your own grandfather before your father was born. And the universe doesn't like paradoxes. It likes things to be tidy. So the speed of light isn't just a limit on speed. It's a shield that protects the sequence of events. It's the glue that keeps the story of the universe from unraveling into a chaotic mess where the end happens before the beginning. Think about that. The reason you can't reach the stars in a heartbeat is the same reason you can't unfry an egg. It's all connected. It's all part of the same grand, ridiculous, wonderful scheme. Now, really, this time, I'm done. Go think about your budget. Spend it wisely. If you want to see more of these mental maps, or if you want me to tackle another impossible concept, leave a comment below. Let's keep this conversation going. The universe isn't going anywhere, well, except toward the future at the speed of light, so we have plenty of time. Stay curious, keep wiggling, and never stop asking the stupid questions, because those are the ones that lead to the most beautiful answers. Would you like me to expand on the block universe concept or go deeper into the mass as an anchor metaphor?